Hey guys, welcome back to another tutorial on Python and its basics. In this video, I'm going to cover what method overloading is. So you probably must have heard uh, that Python doesn't support method overloading. So why do we still use it in Python? Why does Python still support it? So in this video, we'll be covering that, and method overloading is a part of polymorphism, which is in turn a part of object-oriented programming. So what is polymorphism? Polymorphism is a simple idea in programming where the same function or method can behave differently depending on what input you give it. One type of this is called method overloading, which is a form of compile time polymorphism. This means that this decision of which method to call is made before the program runs based on the number or type of arguments which we call as method signatures. So A and B, ABC are method signatures or parameters that determine the which method that is to be called. Okay, in languages like Java, this is done by writing multiple methods with the same name but different parameters. In Python, however, things work differently. Python does not support method overloading in a traditional way because it is dynamically typed. Dynamically typed means you don't have to declare the data type of a variable beforehand. Python automatically decides the type at a runtime based on the value you assign. Okay, so instead, Python lets you handle different inputs using parameters like arguments and keyword arguments, which we'll come to later. Okay, and default values as well. Okay, this entire code snippet is based on default values, which we'll come to. So rather than just creating multiple methods, you write one flexible method that can create different cases, which we are doing in Python. And this makes the code simpler, more powerful, and that's how Python achieves similar behavior without true method overloading. Alright, so in the first snippet right here, we have a class calculator that has two methods. And one of the methods, that is add method, is commented out, and I'll tell you why. But there is another method add, same method name, okay, but different parameters or different signatures. First method takes two signatures or two parameters, that is a and b, and the second takes a, b, and c. Okay, and we initialize the reference variable of type which with the type class calculator, and it is of type class calculator, right? And we use that object to call the add method inside the class calculator. Okay, very simple, nothing complex here. Now I'm assuring you that there is nothing wrong with what the output is going to look like. Okay, for now. So if I just execute this, and it's going to tell us that the result of adding two numbers is 10. Okay, we are sending 5 and b is 5, a is 5 and b is 5, receiving right here. Okay, and there is nothing wrong with what's happening till now. Now say if I uncomment this, now the whole game changes, and Python does not accept this. So what Python sees is that it's reading this first method and then it's reading the second method. So what happens here is Python replaces the second method completely with the first method. So what Python is aware of now? Definitely not the first one. So Python is only aware of the second method. Okay, and we create an instance and we use that instance to call the method. And in this case, we are sending just two parameters instead of three. Now, since Python is aware of a method with three parameters, obviously we're supposed to call the method with sending three parameters, right? So what it tells us is going to be a type error because we are sending two parameters, but it's receiving three, and it's not even reading this method name. Okay, this entire method definition, Python is just overwriting it with the second one. So we're going to get a type error saying that calculator.add method missing one required positional argument c. That means that we are supposed to send another parameter here, but it's over here is receiving another parameter. So it's missing c in this parameter right here in line 10. Okay, so now that we know that Python does not support method overloading, what actually happens is Python reads the first method, then reads the second method, and then completely overrides the first one with the second one. Okay, that's why calling it with just two arguments, it fails, right? So if Python doesn't support method overloading, how do we achieve similar behavior? Then we come to the first approach. Okay, I'm just going to comment this out. We're going to come to the first approach where I had mentioned earlier about using default arguments. So to achieve method overloading in Python, we can use either default arguments or variable length arguments. So default arguments is an example where we use the caller. Okay, if we don't provide it with a argument, then it automatically assigns the value as none. That means when I'm not calling the third argument in this case in line 27, the extra argument automatically assigns itself as none. Okay, we have to provide as none so that we don't get any errors. So in this snippet, what's going to happen is we just have one single method, okay, and we have two calls. So if we provide two signatures or two parameters or three parameters, or in this case as many parameters, numbered parameters, um, we have to provide the extra parameters as none. Okay, so that is what is meant by default arguments. We'll come to variable length arguments where we include arguments and which is returning tuples or tuples to us, and as keyword arguments which returns dictionary to us. Okay, so we use default parameters to simulate overloading here, and if the caller does not provide C, the third value, it automatically assigns it the value none, okay, while receiving it. So we have a method add where it takes three arguments, and the third one is an extra argument, considering that there are two callers right here. Okay, and we create an instance, use that instance to call the method, one passing two parameters and the other passing three parameters. So in this case it's going to print both. Okay, we're going to get the result for both, that is the multiplication and the addition. Okay, so we have the multiplication, that is 750, and the addition, which is 10. Okay, if we multiply 5 into 10 into 150, we get 750. All right, so in the first if condition, we have if C is not none. That means it checks whether we have the third variable. If we don't have the third, if we have the third variable, then we calculate and return the entire parameter list. Okay, we calculate with ABC, we have the complete parameter list, and we return the value. And else, that means if C is none, that means if we don't have the third parameter, then we just calculate with the two parameters that we already have. Okay, that is when we call this. So this is the most common and clean approach. Okay, so I'm just going to comment this out, and we'll move on to a scalable approach using arguments. Okay, this is typically used in scalable systems. And calculator, I'm just going to mention right here, this one, and this one is going to be of type int. Okay, I think all right. So right here we have a class calculator, and it's taking two arguments, that is self and arguments. Okay, so args is in arguments. Instead of this, we can just write the entire, this is not a keyword. Okay, I just want to let you know this is not a keyword. We can just write arguments instead. Okay, what matters is this star symbol, which means that is going to return to us a type tuple. Okay, so I'm just going to follow the naming conventions because most Python developers follow args as to short term it as arguments. So it tells us that if no matter how many arguments you send me, I will first check it. I'll first check the length and do the operation accordingly. So one thing is imperative here, that we do check how many arguments is inside that tuple. Okay, and what is going to tell us is the number of arguments and do the operation. So when we create an instance and call the method and pass as many parameters as we want, if we want, we can even provide 4 parameters like so. but but then we have to mention that how many cases, how many arguments we have, okay, and that will be, in this case it will be 4, so it will be, say, multiplied by args in third brackets 3, okay. So just like that, we have to calculate in that way as many number of arguments there are. So this is an example of method overloading using variable length arguments, okay. The add method right here can handle both cases, or in this case all 3 cases, and it checks if the third argument is provided to determine which operation to perform, okay. So this allows dynamic input handling without changing the function signature. This is useful when you don't know how many inputs you'll get, okay. So arguments right here, we don't know how many inputs we are going to get, so we just iterate through them. In this case, I've just shown it in a very simple way that if there are 2 arguments or 3 arguments or 4 arguments, then we do so and so operation. But what if we don't know the number of arguments here? Then we just run a for loop through it and we just perform the operation. All right. So I'm just going to run this and say it's going to run all 3 callers. Okay. Now we move on to keyword arguments, another way of writing scalable approach, okay. So I'm just going to comment that out and come to this one. So in this case we have class student, and we, in this case I just had a init under method, but in other cases I didn't, which is actually very bad of me and I shouldn't have, and this would be very much recommended in the other classes. So anyway, I'll just mention this. Even if you don't write anything inside, no definition, you still have to, it is imperative that you have to, which is a good practice, I would say. Okay. Why is it showing me? Okay. Okay, so now it's fine. Do the same for other cases. Alright, so now in this case we have class student, and we have a default constructor, and we have a single method display, and it gets the keyword arguments, okay. And to loop through a keyword arguments, that means in the form of a dictionary, we have to use the method items to be able to access its key and its corresponding value, okay. And as you must have seen in my previous videos, which were more complex than this is just showing you in a very simple way that we are taking one single variable as multiple arguments, okay. So keyword arguments can also mean that it has multiple dictionaries within it, so you have to loop through every single dictionary to be able to access its corresponding keys and values, okay. So right here we have a main under method, and we use the instance variable stud1 to call the display. All right, so in this case we have passed a few parameters, that is name, age and email, and we are providing it with a key and a value pair, okay. Now this is only, these parameters are only meant for a dictionary, okay. Now if you pass something like this 60, okay, and it will not take it, okay. It's going to show us an error. Why? Because these are only meant for keyword arguments, and instead of kwargs we can literally give it as keyword, okay, arguments, okay, like this, and there is nothing wrong with this. It is just a naming convention, okay, and it's still going to run. But we don't do that. Python developers provide us with a naming convention, keep it as kwargs, because it's readable and most developers prefer this, and so do I. And what determines that this keyword arguments is a type dictionary is that there are 2 stars in here. So these two symbols, these two star symbols basically align with that keyword arguments, means that it's going to have a key and value pair. So when we pass three arguments, or in this case we are not passing four arguments like this. If you want to send a four arguments, say how about class, did we write class? No, we haven't. So say class equals, and provide a string with 8. Okay, how about that? 8a. Okay, I'm in class 8a. So why is it not, what's wrong with this? Okay, so age, email, class. Okay, since class is a keyword here, we cannot it's an expected expression, positional argument cannot appear after keyword arguments. So we have already written class here, so we cannot write the same keyword. It's so, since Python declares this as a keyword, that's unfair. So instead of class, what else can we give? Say how about identity? We cannot even give ID, I think, because okay, we can give ID. I thought ID is a method, by the way, in Python. So this is just a keyword, a key that we are sending. So I'll just give it a random value. Okay, and I'm not going to change anything here, because keyword arguments are just going to randomly take all the arguments as key and values and print them out. Okay, so like we have here Peter, which is the name, age 20, and the email and the ID. All right, so this is how we use keyword arguments, and this is an example of method overloading using variable length arguments in Python. So now your method can accept completely dynamic named inputs, provided they are in key value pairs. Okay, so I'm just going to close this terminal, comment this out. And now how do we relate this method overloading with real example? Okay, real life. So we have three conditions. We have three calls. I can either call just for food, I can order for food with quantity, or I can order food with quantity and an address that it can provide it to my home address. Okay, now with one argument that we are sending just food, I can only order that give me a burger. With two, it becomes more precise. That means give me two burgers. That means 2 is one argument, that is a quantity, and burgers is another, that is food. And in the third scenario, we have deliver two burgers to my home. That means we have the quantity, the food, okay, burgers, and the address to my home. So this is how we relate to a real life analogy, and same action, different input detail. Okay, same as method overloading, exactly what it is doing. So in Python, we simulate this flexibility using one method instead of multiple definitions. Alright, so far we have seen how method overloading can be achieved in Python using two approaches. One is default parameters and the other is variable length arguments. Now variable length arguments, I've only shown you how arguments and keyword arguments can be achieved in two separate classes, okay, as per the requirement. Now how about we combine both? Now that could also be another requirement where we need arguments also and we need keywords arguments also. Okay, so I'll just close this and I'll open a new file. And in this program, there is one thing that we have to note where we consider arguments and keyword arguments together. So the important note that we have to take from this is we cannot place arguments or positional arguments after keyword arguments. All right, so we don't do that because it is a very strict no from Python. And if we try to do that, that would mean say supposing in this one if I have 90, it would tell me that positional arguments cannot appear after keyword arguments. Okay, it's not cool, so this we do not do. Okay, so I'm just going to comment each and every single one of them out. See, these are all print statements inside the display. So display is basically taking two arguments, that is a tuple as an argument and keyword arguments as a dictionary. All right, so there's a single star that takes returns tuples, and there's a double star that returns dictionaries. Okay, and inside the class student, we have a default constructor which is currently having pass. That means we are not providing any definition to the default constructor. So after having commented all this out, I just want to show you what we are receiving as an argument. So I'll just comment this one out as well, and I just passed one argument. Okay, I'll just run through this, and what we are receiving is a type tuple with inside we have one string value Peter. Okay, and what if I had to print not here, but how about print it here and say the type of the argument would be okay. How about that? What would we get? We would get type tuple. Okay, so arguments always gives us a return type of tuple, and keyword arguments always returns us with a dictionary. Okay, so I'll just print that out as well. How about I copy this and paste it here, and is it the same keyword? Okay, how about this? And what we get now is type dictionary. Okay, and currently it's empty because we are not passing anything to it, and this is being sent as a argument. So argument is receiving it, but we are not printing it. What we are receiving is keyword arguments, but we are not sending any keyword arguments here. So that is why it's not printing anything. Okay, it's printing us an empty dictionary. All right, so we are how about we now we can send two values as an argument as well. Okay, so these two values Kabir and Parker will be contained in arguments as a tuple. Okay, so we get that as a tuple, and we can iterate through this to get individual values as Kabir and Parker. And in the next line we have called John, Parker and 30, which is an integer. So tuples now means that it can take multiple different types of values. All right, so arguments can take different types of values. So when we execute this, we get John, Parker and 30 as in a single tuple. All right, now what if I executed tuples as well as dictionaries together? That means I'm sending arguments, okay, positional arguments, and I'm sending keyword arguments, and as many as I want. Now in this case we have 3 positional arguments and 2 positional arguments, 2 keyword arguments. Okay, all right, so that means that John, Parker and 30 would be receiving in positional arguments. Okay, and the key value pair email and abc@gmail.com and password as 1234 be received in keyword arguments. Okay, so we can have multiple number of arguments, and one thing that we have to note is that in while we pass these arguments to display method, we cannot put positional arguments after keyword arguments. So Python will understand that there are normal parameters, then like say for example we have an integer 90, okay, and then John, Parker and 30 and which will be considered as positional arguments, and these key values as keyword arguments. All right, so how do we distinguish that 90 should be a normal parameter? So instead of assigning parameters like this, we'll first assign a normal parameter which will be received as any value a, okay, which will be of type integer because we are sending 90 here. Now say if this was a string 90, then we would be writing string here or str. All right, so how about now we pass two normal parameters, okay, a string and an integer. So now how do we distinguish that? Now normal parameters will be sent as the number of parameters that we have at first, okay, and the rest of the positional parameters that will be considered as an argument, positional arguments. Okay, so we have two normal parameters, so we need to have another variable b which will be considered as an integer. Okay, but now say supposing if we don't provide b, that will also still be fine, but in this case b will take 90 this positional arguments will take 90. All right. So that would mean that since we are not giving b and we are only providing one normal parameter a will only take 90 as a string. It will not take this. But if we provide b right here, okay, as an integer, then it will take b will take 90 as an integer. Okay. I'm hoping that I'm pretty clear with this with everyone who's watching this video. So this is not very complex. It's basically how the syntax in Python is followed. And see, if I comment this out and show you another one, I just print out keyword arguments. All right. And since I'm not passing any arguments and no normal parameters either, I'll just remove this to follow the convention. And which print follow? I'm printing only keyword arguments, so I'll go with this. Okay. And in this keyword, this is a print function where we have a print method where we have an email and password that we are trying to print, and the keyword arguments and the key. Okay, so this is going to give us the value of the keyword argument email. Okay, so if I just have to print this out, it will give us as email. Okay, and the value of the keyword arguments as email. That why do we write this is because we have passed email as a parameter, as a keyword argument, as a key, okay, to the argument that is received in the keyword arguments right here, which is a dictionary, which is a key in this dictionary right here. Okay, so if we say change email to email underscore address, then that would mean when you receive it here, the name of the key in this keyword arguments would be email address. So we would have to write email underscore address similarly to match the key, right? Otherwise we'll just straightforward get a error, I mean that the keys don't match. So how about we show that first? It's telling us that email, okay, keyword arguments password, it's doesn't match. Okay, it's not telling us, simply tells us that it doesn't match. Okay, so how about we give it the same, we follow the naming convention. All right, so and in the same case we get keyword arguments with password, which we get the value for this key. Okay, and we print that out like so. Okay, so method overloading matters because it improves code reusability, API flexibility, readability when used correctly. All right, so the order matters very much here. In first normal parameters, then positional arguments, and then we go with keyword arguments. All right, but in Python we achieve this through design, not language features. All right, so this entire concept fall under polymorphism, and polymorphism means same interface different behavior, or same interface different arguments. So in Python this is mostly achieved using method overriding, duck typing, flexible arguments. So a quick distinction would be overloading is what? Same method name, different parameters, not native in Python. Okay, Python doesn't support this, but we have still achieved it using certain rules that by following default parameters and variable length arguments. All right, so overriding means child class modifies parent class method, which is fully supported in Python. Okay, in real backend systems, Django API services, you rarely overload methods. So here's the bottom line: Python does not support traditional method overloading, but default arguments, positional arguments, keyword arguments are key ways to approach it. It gives you something more powerful, that's flexible function design. Okay, if you want more practical Python concepts explained like this, especially for backend and real world use cases, do stay tuned. Next, I'll be covering method overriding in depth, which Python actually supports properly. So I'll see you on the next one.